A body of mass m slides down a smooth inclined plane and reaches the bottom with the speed v. Calculate the speed with which this body reaches the bottom if it was in the form of a solid sphere and rolls down without slipping. First case, body slides down and gains a velocity v. Second case, body rolls down, then what is the possible final speed? Second case, the body is given as a solid sphere. So we know that the sphere moment of inertia I is given by 2 by 5 mr square. So if I compare with our standard equation beta into mr square, the shape constant beta is equal to 2 by 5. Now let us take this sliding case. If I consider as v1 root over 2 into g sin theta into L, take it as equation 1. Now take ruling case. Let us call velocity as v2, 2 into g sin theta by 1 plus beta into L. Now if I take the ratio between v1 and v2, so here root 2 g sin theta, here root 2 g sin theta is cancelled, remaining is root over 1 plus beta. Now v2, second case is our interest, v1 is given as v divided by root over 1 plus beta. Already we know beta is nothing but 2 by 5 in the case of solid sphere. So this becomes root over 5 by 7 v. LCM is 5, 5 plus 2 is 7. 7 by 5 goes to the numerator and becomes root 5 by 7 v. The speed gained by the ruling body, ruling solid sphere when it reaches the bottom is root over 5 by 7 v.